Here is your homework for Unit 7. This is Target 3, solving a square root equation. There's a really good reminder here in the directions to check for extraneous solutions, so we will make sure to do that. So on this first one, on all of them, we are going to get our square root by itself, which means we've got to get rid of this 2. So I'm going to start by subtracting 2. So we have the square root of v plus 5 equals 2. Now that our square root's by itself, we're going to square both sides. So we have v plus 5 equals 4, and subtracting 5, we get v equals negative 1. Before we can finish this problem, we do have to check our work. That is part of the process here in Target 3. So plugging that back into the original problem, and let's make sure this is a true statement. So negative 1 plus 5 is 4, so the square root of 4 plus 2 should equal 4. Square root of 4 is 2. 2 plus 2 does equal 4. So that's all good there on number 1. On number 2, when you have a square root equals a square root, just square both sides. It lifts off the radical of both sides. It looks like the hardest case, but it's actually one of the easier. Now I'm just combining my like terms. So now I have negative 6 equals 1x minus 12. Adding 12 to get x by itself, x equals 6. Let's check for those extraneous solutions. So plugging it back in. 2 times 6 minus 6 equals the square root of 3 times 6 minus 12. All right, 2 times 6 is 12, minus 6 is 6. And then 3 times 6 is 18, minus 12 is also 6. So we get the square root of 6 equals the square root of 6, and while that is a decimal, that is a true statement. There's no negatives under the square root either, so we are good to go. Moving on to number 3, it's very similar to number 2. We're going to start by squaring both sides. So I have the square root of negative, I squared, so I don't have the square root anymore. Negative 17 minus 2a equals negative 8 minus a. Add the 2a over. So I have negative 17 equals negative a. Negative 8 plus a. Adding 8. So I have negative 9 equals a. I'm going to go ahead and check that. So I'm plugging it back in to the original problem. This is minus a negative 9, so that is going to end up being a plus. So over here, negative 2 times negative 9 is positive 18. So this is negative 17 plus 18, which is the square root of 1. And then over here, we also get the square root of 1. So that's a true statement. So answer 3 is negative 9. No problems there. On number 4, we've got to get rid of that negative 5 out in front. So I'm going to start by dividing to get rid of that negative 5. So I get the square root of 3r minus 5 equals 4. To get rid of this square root, square both sides. So I'm going to add 5. So I get 3r equals 21. So r must be 7. Let's check that out. Plugging it back into the original. 3 times 7 minus 5 equals 20. Okay, so under the square root, 3 times 7 is 21, minus 5 is 16. So negative 5 times the square root of 15, that's got to be negative 20. And the square root of 16 is 4, so this does end up being a true statement. No extraneous solutions here on the front. Let's check out the back. On number 5, in order to get rid of that square root, let's square both sides. My goodness, I got rid of the square root. So that's negative 1 minus 2x equals x squared. And this is actually a quadratic, so we have to have it equal to 0. So to keep things positive, I'm going to add the 1 and the 2x over here. So cleaning that up a little bit, I have x squared plus 2x plus 1. So to solve this quadratic, numbers that multiply to 1 and add to 2, those numbers would be 1 and 1. So the factors would be x plus 1 and x plus 1, which means my solution would be negative 1. I don't need to write that twice. You just have to write it once if you have that double like that. But we do need to check our work. So going back up, so negative 1 square root of negative 1 minus 2 times negative 1 equals negative 1. So I just replaced the x's with negative 1's. So negative 2 times negative 1 is actually positive 2. So negative 1 plus 2 would be square root of 1. The square root of 1 is not equal to negative 1. The square root of 1 is equal to positive 1. Throw out this solution since there's nothing else left. This is a no solution scenario. All right, on number 6, have to get rid of that 6 plus out in front. So I'm going to subtract 6. And then to get rid of the square root, I'm going to square both sides. And then solving, I'm going to subtract 7 and divide by 2. So we get r equals 9. Let's check our answer. All right, so under the square root, 2 times 9 is 18, plus 7 is 25. So this is 11 equals 6 plus, and the square root of 25 is 5, and 11 is equal to 6 plus 5. So 9 equals r is our answer there on number 6. On number 7, to get rid of the square root, we're going to square both sides. So we have b squared equals 110 minus b. And then because this is a quadratic, I'm going to get it all on one side. So I'm going to subtract 110 and add b. So cleaning that up, that looks kind of crazy. We have b squared plus b minus 110 equals 0. So solving a quadratic means factoring. So I need numbers that multiply to negative 110 and add to 1. Those numbers would be 11 and negative 10. So our factors would be, let's use b, trying to change it to x there, b plus 11 and b minus 10, which means our possible solutions are b equals negative 11 and b equals positive 10. Let's check those two answers, plugging them back into the original equation. So starting with negative 11, so that would be negative 11 equals the square root of 110 minus a negative 11, which would be plus. So negative 11 equals the square root of 121. That's actually a false statement. The square root of 121 is positive 11, so we need to throw out that answer. Let's check on 10. So 10 equals the square root of 110 minus 10. 10 equals, oops, lost my equals. 10 equals the square root of 100. Square root of 100 is 10, so that is a solution, only one here. And then on our last problem, in order to get rid of the square root, we're going to square both sides. But remember, we have to square this entire side, which means it's a plus 4 times a plus 4. It lifts the square root off of the right-hand side. So we're going to go ahead and FOIL out, or multiply out, a plus 4 times a plus 4. So that would be a squared plus 4a plus 4a plus 16 So 4a plus 4a is 8a. And then because this is a quadratic, I need to get everything on the same side. So I'm going to subtract 6a and also subtract 15. So I have a squared plus 2a plus 1 equals 0. So numbers that multiply to 1 and add to 2, those numbers are 1 and 1, which means our factors are a plus 1 and a plus 1, and which means my only possible solution is negative 1. Remember, we don't have to write that twice when that happens. Okay, so let's check our answer here. Back into the original equation, that would be negative 1 plus 4 equals the square root of 6 times negative 1 plus 15. So negative 1 plus 4 is 3. 6 times negative 1 is negative 6, plus 15 is 9. The square root of 9 is 3, so that's a true statement. So only a couple extraneous solutions out of those 8 problems, but that is your homework for Target 13.